So how can we reduce the inharmonicity and strengthen the pitch? We have those frequencies, and they are not integers. They have the natural frequency, and the second, third, and fourth modes are not integers, multiples of natural frequencies. Those fractions are not quite simple. Yeah, this formula still for the nth mode frequency. How can we reduce the inharmonicity and strengthens the pitch? Here we have first and second pitch mode. You can add a resonator tuned to F1. So we get a resonator and hit at the middle of the bar to decrease F2 and decrease the thickness in the middle of the key. Okay, so now we know that. We have some lengths here. Pitch C3, C4, C5, C6, C7. The frequencies are growing and the length is smaller of the bar. Okay. The cautions from per, through, plus quaterna to strike and shake, marimba, xylophone, vibraphone, and a glockenspiel. And so there's a, I don't know what's called this, percussions. The marimba and the xylophone are made out of wood. Silent means wood. The vibraphone and the glockenspiel are made of metal. So this is marimba and xylophone is wood, and the vibraphone and glockenspiel are metals. The marimba and vibraphone have resonators, sometimes also the xylophone. The marimba and vibraphone, okay, they have resonators, and sometimes also the xylophone. Okay. The marimba has a much larger note range than the xylophone and a duller timbre. The marimba is often used in solo and the xylophone in orchestra. Okay, marimba and xylophone. The vibraphone, often used in jazz as a motor in the resonator to generate and modulate sound. See figure below. Okay. Glockenspiel can be played in marching band. It has a bright inharmonic sound like a bell. Glocken equal to bell in German. So design a marimba key with a 1 centimeter thick bar of rosewood. Speed of sound is from 5,217 meters per second to play at 440 Hz. Give the dimensions of the bar and the resonator. Again, I use the equation and put the numbers in the equation in the Fn term and solve it according to L, and I get a length of for the length of the bar to almost 35 centimeters. About the resonator, I don't know. Example of other non-common idiophones. Acoustics of a percussion tube with 3 ends. This is slagwork still this term for the frequencies. Speed, LBL, speed of sound in the bar. And now K is the inner radius squared plus the outer radius squared, so a different, so it's K here instead of thickness, and L is still bar length, and Mn is the same as before. Remark here that the slagwerk, it's a transverse wave like in a string. It's different from the tube percussion, which is longitudinal, follow open or closed tube. Okay, so here this is transverse waves here. Transverse wave here in this slagwerk, different and longitudinal waves in tubes percussion. Okay, different types of waveforms in here. Then we have a kalimba percussion bar with one free end. We go back to the same occasion as we have seen before. VL is the speed of sound in the bar, thickness T, L bar length, and Mn, but Mn is now some different numbers here. Mn is 1.194 and then 2.992988 and 5 and 7 and so on. I don't know why it's like that. Jaw harp is like a Helmholtz frequency. F is C divided by 2 pi, and some area from B to C here in the nominator, and the denominator is a volume from A to B here. This one we see here in the mouse, and the length from B to C here. The length from B to C is okay. Yes. A crystal basket. Saxophones. Benjamin Franklin's glass harmonica. Sounds special. Okay, and then we go to membraphones. It's defined as any of a class of musical instruments in which a stretched membrane vibrates to produce sound. Any of a class of musical instruments in which a stretched membrane vibrates to produce sound. Then, okay, membrane. It could be a drum or something. Okay. So we see here acoustics of a membrane. Figure 10 modes of a stretched drum membrane. The mode numbers are given in the brackets. Number of diametric nodes, number of circular nodes. Plus and minus signs show the relative phasing of the vibration of different parts of the structure within each mode. So here is a 0. First one is 0 diametric but 1 circular. This gives us number 0, 1. And here is 1 diametric and 1 circular is 1.1. Here's 2 diametrics, 1 and 2, and 1 circle, 2.1. Here are no diametric but two circular, so 0,2. Here are 1, 2, 3 diametric, is number 3, and one circular. And here is 1 diametric and 1, 2 circulars. Here are 1, 2, 3, 4 diameters, or diametric is number 4, and 1 circular, 4,1. And here is 2.2, 2 diametric, one here and 2 circulars. Here's 0.3, 1, 2, 3 circulars, and no diametric. And here is 5 diametric and 1 circular. You see 1 circular. 1, 2, 3, 4, 5. Okay. So it's some terminology. So we have here acoustic of a membrane. This formula, if m, n, we get T is the tension of the membrane, A is a radius, sigma, small sigma is the density, and x m, n is the value of the nth non-trivial zero of the mth order Bessel function. Mx mn is the value of the nth order non-trivial zero of the mth order Bessel function here. It's complicated stuff. So this Bessel function is for m equal to 0 and n 1, 2, 3, 4, 5. Then we get for m0 we get those Bessel functions are 0 when x0.n is k, the Wayne number, times a, the radius of the membrane, and we get 2.4, 5.5, 8.6, 11.79, and so 14.93 respectively. We can calculate those things, and we get some numbers here. Down here, vibration frequencies of a circular plate with clamped edge. Those Bessel functions are a little bit complicated here from fundamentals. You see 0 Bessel function here, J0, and the modes are, it's 0, about 2.4, and then again, you follow this curve here, 2.4 is 0, and then 5.5, and then 8.6, and then 11.8 almost. So yes, that's it. Yeah. Acoustics of a membrane. We have again the formula. There are no harmonic overtones. Can be tuned by changing the tension. Clamping means den er spændt. Okay. Musician hits at 2/3 of a radius to minimize circular mode. Okay. 2/3 of the radius to minimize circular mode. Okay. Then we know that. We have a timpani, a spring here, some sounds here, stuff here. It's a very effective music instrument played in Handel's Sarabande with Barry Lyndon movie. Okay, I continue later. Thank you.